Hello everyone, this is the second lesson for section 1.1, ratios, and you'll still be comparing two quantities to solve problems. Okay, so now we're going to have some example problems. That's what today's lesson is mostly going to be with, is our example problems. So use a table, and that's this table over here. I'll move this away so you can see it. To write a ratio in each of the three ways. Remember, each of the three ways to write a ratio is a fraction, using the colon, and the word to. So you're going to be doing it all 3 ways. But let's first write it one way. So let's see what it says. Julius's number of green jelly beans to his total number of jelly beans. So now we need to know, if you're looking at this chart, you're seeing that you only have red, purple, green, blue, but you don't have a total. So let's find out what the total jelly beans he has. So 4 plus 3 is 7, plus 3 is 10, plus 2 is 12. So we now have the total number of all of his jelly beans. So it's green jelly beans. We're only looking at green in this case, okay? Green. So it's going to be that first ratio is going to be 3 over 12 as a fraction. And remember, you must always reduce your fractions when writing a ratio. So let's simplify this. So what number goes into 3 and 12? And that is going to be 3. Divides into both 3 and 12. So your ratio is going to be 1 over 4. And now let's just rewrite this 1 over 4 as a colon and using the word to. So 1 to 4 and 1 to 4. Okay. Luke's number of green jelly beans to his total number of jelly beans. So now we're looking at Luke, and we're looking at green and his total. So we're going to be adding all of these up again. So 2 plus 3 is 5, plus 3 is 8, plus 1 is 9. So it's going to be 9 over, not 9 over, see? I'll make a mistake too. So 3 over 9, and the same thing that we did for Julius, we got to do for Luke. We need to simplify the fraction if simplifiable. So 3 goes into 3 and 9, so this simplifies to 1 over 3. And let's just rewrite this as a colon, 1, 2, 3, and then using the word to, 1, 2, 4. C. Did Julius or Luke have a larger ratio of green jelly beans? So we're looking at these two fractions. So sometimes it's easier to compare using a fraction. So 1 over 4 and 1 over 3. And if you're not sure of this, try to create an equivalent fraction, all right? And by creating an equivalent fraction, you need to find a common denominator. Okay, so what are multiples of 3 and 4? And I'm just going to write this out in blue so you can see you have 3, 6, 9, 12, 15. These are called multiples. You're just multiplying 1 and then 2 and then 3 to 3. So multiples of 4 are 4, 8, 12, 16. And what's the smallest number they have in common? That's a 12. So that's what our denominator that we're going to try to create equivalent fractions for is using a 12 at the bottom. And now, what are you multiplying to 4 to get to 12? 3. So you got to do the same exact thing to the top. So you're going to have 3 over 12. Same thing over here. What are you multiplying to 3 to get to 12? 4. So you multiply the same thing to the top, and you're going to get 4 over 12. This is a larger chunk of the pie. Think of like a pizza pie with 12 slices. Who has a larger chunk of the pie? In this case, it's the 4 over 12, which is the 1/3. That would make it Luke. Luke is the one that had the larger ratio. Okay? Let's go on to the next example. All right, and this one is going to be using a tape diagram. That was one of our key vocabulary words from the notes the other day. Trudy and Kay talk on their cell phones each day after school. The ratio of minutes talked by Trudy compared to the minutes talked by Kay is 2/5. This just means that Trudy is the 2 and Kay is the 5. It always goes in order. What is the ratio of minutes talked by Trudy to the total minutes talked? So when you're using a tape diagram, you're just creating the pieces first, and they're all going to represent the same amount. So Trudy has 2 pieces. So we're just going to draw 2 rectangles. Try to do your best in drawing them exactly the same. No one's testing you on that. Just don't make them too different. And now K has 5. So you're going to do 5. 1, 2, 3, 4, 5. All right, so this is your tape diagram from Trudy to Kay. If the girls talked for 42 minutes today, how many minutes did Kay talk? So we know that the total is 42. So what matters here is that if we're looking at the total minutes, that means we need to know the total number of parts that we have here. So we have 1, 2, 3, 4, 5, 6, 7 parts here. So you're going to be dividing this 42 by 7, and you're going to get 6. So 6 times 7 is 42. So that is how many minutes are in each part, because we split up. We're trying to find out how many were in each part. So that means this is 6 minutes, this is 6 minutes, this is 6 minutes, and so on. So I'm just writing 6 in all of them. So the question is ultimately asking how many minutes did K talk? So K is the one down here. So I'm going to write this in a different color. So K has how many parts? 1, 2, 3, 4, 5. She has 1, 2, 3, 4, 5 parts. So that just means you're doing 6 times 5, which is 30. And we always try to write the actual units that are talking about here. So this is going to be 30 minutes talked by K. If you were trying to find Trudy, you would just do 6 times 2 in this case, and it would be 12 minutes. All right, let's do another example problem in a different way. The ratio of cars to trucks in the parking lot is 6:5. There are 36 cars in the parking lot. How many trucks are in the parking lot? So you have the ratio of trucks to trucks in the parking lot is cars to trucks. So cars, trucks. So 1, 2, 3, 4, 5, 6. And I'm just going to make it similar size because we know there's 5 in this one. So 1, 2, 3, 4, 5. There are 36 cars in the parking lots. Okay, so we know that the total of this is 36, and there are 6 pieces. 1, 2, 3, 4, 5, 6. So what we're doing this time that's different from the other is we know that there's 6 parts here, so we're going to be dividing this 36 by 6. So that is 6. So each of this represents 6 vehicles. So 1, 2, 3, 4, 5, 6. So that means this is going to be 6 as well because they all represent the same amount. So I'm just putting 6 in all of them. Okay. So how many trucks are in the parking lot? 1, 2, 3, 4, 5. So this is going to just be 6 times 5, and that is 30 trucks. Okay. Marcy's teacher assigned 4 math problems for every 3 science problems. Complete the ratio table to show the relationship between the number of math problems assigned to the number of science problems. So when you're trying to complete a table, you're trying to find the information you know. So what are you doing to 3 to get to 6 over here? You're multiplying by 2, so that means you have to do the same thing to the top. So this is going to be 8. And then look at the 4 do this in a different color since pink and purple are my. What are you doing from 4 to 40? You're multiplying by 10. So that means you got to do the same thing to the bottom. Multiply by 10 and you're going to get 30. So you're just completing the table. All right. And one more example after this. Try to do it on your own. See if you get it right. Then watch to see if your answers match. So you're completing this table. Raul's orchard picks 9 apples for every 5 pears. So let's look at the pairs first. So what are you doing to 5 to 20? You're multiplying by 4. So that means you're doing multiplying this by 4. Okay? Same thing to the top. What are you doing 9 to get to 108? And if you need to use a multiplication table or a calculator for this, it's okay, but it's not a bad idea to divide 2 if you want. 9 goes into 10 one time, so 1 times 9 is 9, subtract 18, 2. So this is 12 times. Same thing over here. 5 times 12 is 60. This is completing the table. I hope this helped you understand ratios. Thanks for joining. Bye.